Hey everybody, tonight we have a problem with a fairly straightforward solution, and that's understandable. You'll notice it was problem 1 in a math competition, Carnegie Mellon, 2020. Now you can rewrite the given here is x squared is equal to 18x plus 11. Okay, and we're assuming that x is a real solution. Now I guess the problem composer said that for emphasis. It turns out there's only 2 real solutions to this particular quadratic expression, but I guess he's emphasizing that if it's not real, then you couldn't get this integer representation, linear form representation for a solution cubed. Okay, so this may be superfluous, but it would only work for real solutions. Now, so we're looking to show that any real solution to this expression can be cubed and written in a linear form where a and b are integers. Okay, so again, all this is very straightforward here. X cubed is equal to x times x squared. Well, x squared is 18x plus 11. There you go. When you multiply it out, when you multiply this out, you do it, and you have x squared again. So you substitute it twice. You see, it's just a double substitution. Nothing straightforward. Not super challenging. Now this ends up being, let's see, 18 times 18 is 324. 324 plus 11 is 325. Oh wait, 324 is 335, excuse me. So that's 335x plus whatever 11 times 18 is, and that's 180 plus 18, which is 198. Okay, so there we go. All right, so there you go, folks. We have this is equal to x cubed, and we're technically done right now. I do want to show you a concrete example. Here it's not hard to show that the 2 solutions here by completing the square are this, 9 plus or minus root 92. Now notice that this would be equal to 9 plus or minus, let's see, 92 is 4 times 23, square root of 4 is 2. So you would have 9 plus or minus 2 root 23. Okay. And that's what happened right here. And again, y'all, 92 is equal to 4 times 23 is what makes that one tick. Okay, and you can take the square root of 4 to get the 2 that you see right here. And so anyway, this is just some work. I expanded this out and got this. So that this is the cubic portion, right? This is x cubed. And I'm just using the plus solution. I didn't check the minus solution. I just did. I'm sure it'll work. But the plus solution, when you expand it out, you get this. Okay, and also this linear form here. Remember, we got 335, right? Up here. And so that's the 335 that you see right here, right? This 335 came from what we just showed up here. When you multiply that out, you get the 2 green objects. So it did check out, even though an abstract mathematician wouldn't care to even check something like this. There's no doubt that these algebraic steps are accurate, and so they would just stop. But anyway, that we did actually show the result, and we were done when we actually got to this form, because 335 and 198 are proud members of the integers. Okay, we'll put member Z like that. Okay, and y'all, so I think this type of setup would work for any integer quadratic. I don't see what could fail here. If any integer coefficient quadratic would lead to this, and then that you could probably generalize it. I may do that on another video, but in any event, we got it done for this problem. I guess you can call this the answer if you want to, right here. And then, of course, this part down here that I showed you is just the check. Thank you for viewing.